What's happening, guys? Welcome to part 6 in the series on facial recognition. In this series, what we're doing is we're going from a state-of-the-art research paper and building up a full-blown implementation with the final end product being an app which integrates that model and allows you to actually use it in real time. In this part of the series, we're going to be focused on evaluating and testing out our model, which we just finished training. Let's take a deeper look as to what we're going through. So in this part of the series, what we're going to be focused on is testing out the model. So in the previous video or part of this series, what we did is we finished training our model using our Tensorflow implementation. Now we're going to test it out. So we'll actually be able to see how well it actually performs. So we'll test it out. What we'll then do is we'll evaluate our performance. So we're going to be using precision and recall to evaluate how well our model is actually performing. And then last but not least, we're going to save our model down so we can begin the processes of actually building this up for deployment. Ready to do it? Get to it. Alrighty, guys. So welcome to part 6 in the series on facial recognition using a Siamese neural network. So in this part, what we're going to focus on is step 6 and step 7. So I'm just going to add in a couple of cells so we can see what the hell we're working on here. All right, so step 6, we're going to focus on evaluating the model. And in order to do that, we're going to be using two key metrics. These are precision and recall. So ideally, these aim to measure how accurate our model is and how well it's actually performing classification. Now, if you wanted a deeper explanation of these specific metrics, I'll link to some stuff below so you can see exactly that. So what we're going to do here is we're actually going to run those metrics and calculate them for our Siamese neural network on specific batches. And then we're actually going to make some predictions, because up until now, we've really gone and done a whole bunch of training and a whole bunch of pre-processing to actually get to this step. But we haven't actually gone and done our evaluation. So that's exactly what we're going to do here. And we're also going to save our model so we can actually go and use it when it comes to actually deploying some stuff out. So first things first, what we need to do is import some metrics in order to perform our evaluation. Now remember, I said we're going to be using precision and recall. So let's go ahead and import these. Okay, so I've gone and written one line of code there. So I've written from tensorflow.keras.metrics import precision, recall. So these are two metrics that you're able to get from the Keras library. So if I type in Keras metrics, there's a metrica, whatever. So there's a whole, let's actually bring up the TensorFlow version. TensorFlow. God, my typing is a shocker today. All right, so there's a whole bunch of different metrics that you can use here. So what we've chosen to use is precision, which you can see that there. So right over here, and recall. So in order to use these, we are effectively going to do what you can see down here. So we're going to set up the metric. We're then going to update its state, and then we're going to calculate the result. So we can do that pretty easily using our model. Now we can do something similar for recall. It's pretty much the same, really. We're just calculating a different metric. But it is good practice to look at a number of different metrics whenever you're going and building out models, because this gives you a better estimation of what it's performing well versus what it's performing not so well at. Okay, so we've got our two different metrics that we're going to calculate. And whenever you're using precision and recall, a higher number is a better number. So ideally, that's what you want to look for whenever you're evaluating any metrics or KPIs, whether or not a higher number is better, or whether or not a lower number is better, whether or not a negative number is better, whether or not a positive number is better. Okay. So we've got our metrics. What we now need to do is actually go on ahead and make some predictions. Now, before we do that, we want to grab a batch of data. So let's grab a batch of data, and we're going to do it from our, where is it? Keep scrolling. Nope, maybe it's a little bit further down here. We're going to do it from our test data, which I believe we created. Yeah. So we created our testing partition. So we're going to be using this data to actually test out our model. So let's go on ahead and grab a part of our partition, and then we'll actually be able to compute these metrics. Okay, so that is our test data now collected. So what I've gone and done is I've again written one line of code. And what I've written is, first up, let's focus on this. So what I've written there is test underscore data dot as numpy iterator, and then I've passed through a set of parentheses dot next. So this is going to convert our TensorFlow data set into a numpy equivalent. So if I run test underscore data dot as numpy iterator, what you're actually going to get back is this numpy iterator. So basically it's looping through and dynamically producing one batch of data back. Now, if I type in .next, it's going to get the next batch of data. So you can see how TensorFlow actually uses this and continuously goes to the next batch, next batch, next batch, next batch, so on. Now, what we can do is we can use this to grab a batch of data. So what we're actually going to get back is three things. So if I store this in a variable, so I'm just going to call it test var, super descriptive variable name. So if I run test var and take a look at its shape, let's put in a NumPy array first. What have we done there? NP array could not broadcast shape into, what have we done? Oh, because it's going to be three different, let's just have a look at the length. So what we've actually got is we've got three different variables inside of this test var variable here. Now, the first variable is going to be our test input. So think of this as eventually what's going to be coming directly through our webcam. So if I grab the first value, this should be 16 different components or 16 different samples. So you can see we've got 16 test inputs. Now, if we take a look at the second value, that's going to be our validation data. So remember, we're going to either be passing through a positive or a negative sample to our Siamese neural network in real time. So ideally, the second one is going to be whether or not it's a negative example or a positive example. So again, we've got 16 of those. And for our third value, and let's take a look at the shape of that or what it actually looks like. So again, we've got images here. And then the last thing that we're going to have is the labels. So this is whether or not the values match or not. So basically it's the classification label. Now we can delete this. So what we've actually gone and done as part of writing this line is we've actually gone and unpacked it in real time. So we're grabbing the test input, the test val, and y true, which is effectively our labels. So the full line of code is test underscore input, comma, test underscore val, comma, y underscore true, equals test underscore data dot as part numpy iterator, and then parentheses dot next, and then parentheses again. And that's what we're getting back. So we've actually got these values pre-unpacked. So if I take a look at test input, those are going to be our input images. Test val is going to be our validation data, and y true is going to be our labels. Boom. Cool. So now what we need to do in order to calculate our precision and recall is we're going to pass through our test input and, well, let's unscrew that. We're going to pass through our test input and our validation data. We're going to make predictions, and ideally what we'll get back from our model is whether or not it is a verified person or a non-verified person. So let's go on ahead and make some predictions. Okay, and there we go. So we've now got our predictions back. So we went and wrote, what is that, 2 lines of code there, and one of them is just rendering the results. But what we've effectively gone and done is we've gone and used this Siamese model, which we went and ran our training loop on already, right up here in steps, really in step 5. So we trained it all up, and now because we've gone and trained our model up, we can go and use the predict function to actually make a prediction. So what I've written is predictions. This could just as easily, actually, let's be consistent. So predict should be equal y hat, y underscore hat. All right, so we've written y underscore hat equals Siamese underscore model dot predict. And then inside of parentheses, we've passed through a set of square brackets. And remember, when we use our Siamese neural network, we're going to pass through our 2 streams. We're going to pass through our input data and our validation data, so either our positive or our negative samples. In this case, what we're doing is we're passing through the values that we got back from our NumPy iterator. So I've written y hat equals Siamese underscore model dot predict, and then inside of square brackets to that function, we're going to be passing through test underscore input and test underscore val. Now remember, order is important here as well. So the input first and then the validation data. And then the next line is just rendering that result. So I've written y hat. And these are our predictions back. So you can see that we've got some positive examples. So this is going to be a very small number. So 1.0779765 to the power of a -5, which means it's going to be a value closer to 0, which means it is a negative sample. This is 1. So you can see 1.000 to the power of 0, which means it's going to be a positive example, or effectively 1. Let's see if we've got any other positive. So there's a positive and there's a positive. All right, so what we can actually do now, and these look like they're pretty large numbers as well, so they're 0.99 effectively. What we can do is we can convert these into a classification output, so either a 0 or 1, so a binary outcome. So in order to do that, we basically just need to set some conditions. So over a certain threshold, we're going to say that that is a 1 or a positive example. So let's go ahead and do that. So it's a little bit more interpretable. So what are we doing? Post-processing the results. Okay, let's do it. Okay, so what I'm doing there is a list comprehension. So what we're effectively doing is we're going to be looping through each one of the values inside of our y-hat example, and we're going to be converting it. So the threshold that I've set is 0.5. So let me break this down. So I've written for prediction in y-hat. If y-hat is greater than 0.5, then return 1, else return 0. So this is just a list comprehension. It's a little bit of it's very Pythonic in the way that you interpret data, but basically it's just doing a loop and we've got an if statement here. So the full line is inside of square brackets. I've written 1 if y-hat is greater than 0.5, else 0 for prediction in y-hat. Now the other way that you could write this is for prediction in y-hat. So you'd have a results array. So res equals that array for prediction in y-hat if y underscore hat is, if prediction is greater than 0.5, then what are we doing? So we are going to go res.append 1, else res.append 0. So we're effectively converting this series of confidence metrics into a binary outcome, so 0, 1. Now, we don't want to run it like this because it's not super Pythonic, so we're going to do it this way. And I've gone and done something wrong. So for prediction in y-hat, if y-hat is greater, this should be prediction. There we go. Okay, so what we've actually got there is we've got the results of our y-hat output over here. So you can see that rather than having these values, which are a range or a continuous value, we've actually got a binary outcome now. So 0, 1, 0, 0, 1. Now what we can do is we can actually compare that to our labels that we extracted from up here. So if we go and take a look at that, so what was it called? Y true. Let's take a look. So we've got 0, 0, 1, 1, 0, 0, 0, 0. This is actually looking very good. So 1, 1, 1, 1. So that's what, 6 ones? 1, 1, 1, 1, 1. I think we might have a pretty good model there. Yeah, that's looking pretty good. So you can see that that actually matches that exactly. Now, rather than doing this manually and visually inspecting it, we can actually go and use our metrics from up here to actually test this out. So let's actually do that. Okay, so that is our metric now calculated. So a couple of errors there. I was just typing stuff in or passing through the inputs in the wrong format. So I had this inside of square brackets, but that's perfectly fine. It's resolved now. So let's actually break this down. So first up, what we're doing is we're creating, so we've actually written 3 lines of code there. So we're creating a metric object. And this is a metric object for recall. So I've written m equals recall and then inside of parentheses or set of parentheses at the end. Then what we're doing is we're updating the state. So this is effectively like calculating the recall value. So I've written m.update state and we're actually passing through 2 positional arguments to this function. So we're passing through y true, comma, y hat. And this is what actually passes that through to our recall object. So then what we can do is access the result using m.result, and then we're converting it to a NumPy array. So, or NumPy value. So return result or recall result. Cool, so 3 lines of code, and you can see there that our recall is 100%. So in this particular case, we've got a really good output or a really good model that's accurately able to identify us versus other people. So again, pretty good in this case. Now, if we wanted to, we could actually calculate precision as well. Just a key note on that. So recall, a higher value is going to be better, and precision, a higher value is also going to be better. So again, in this particular case, we've got 100% for recall, and if we do precision as well, again, 100%. So in this particular case, this is pretty good. But just keep in mind, we've only done this on a single batch. So best practice would be to calculate it over the entire test sample rather than just doing it on one. Okay, now if we wanted to, we could actually grab another batch. So all we need to do is run this line here again. So if I run that, run that. And then again, so just to prove, you'll actually see that these values actually change, right? So we're going to get different predictions. Boom. And if we take a look at our Y true values, again, different values. If we go and now calculate precision, again, 100%, we can switch it back to recall. So again, we've got a pretty good performing model, given the fact that we only trained for what, like 50 epochs, and we passed through, what was it, like 300 lines of data? Or 300 examples or samples. How much data did we actually pass through? It was somewhere up here. It should have been take. This is our anchor and our positive. I'm trying to work out how much data we brought. Yes. All right. So we took 300 samples, right? So with 300. So on just 300 images of data, we've been accurately able to identify myself versus other people. So again, pretty good in terms of facial verification. Now, so that is done. Now, what we can also do is we can also visualize these results. So I'm telling you that they match, but you can't actually see anything at the moment. So let's actually go on ahead and plot some stuff out. Let's also break this out into some sections. So this first section here, we're going to call it 6.1, so import metrics. And then we are going to get a batch of data, or we'll actually call it make predictions. And then down here, we're calculating metrics. And we can also just copy this down. So we've got recall separately, and we can have precision separately. Cool. And then the last thing that we want to do is actually visualize our results. So let's actually create another section for that. What are we up to? 6.4. Viz results. Okay, so what we're going to do now is we are actually going to compare the results for different samples in our batch. So let's go on ahead and do this. Okay, and that is our data now visualized. So can we zoom out a little bit? This is a bit big on the screen. All right, so you can see there that what we've actually got is the positive example. So this is going to be our input. This is going to be our validation example. So by passing through our first instance, let's actually take a look at our outcome. So you can see that the result for that particular prediction is 1, which means that this is effectively saying that the people in both of these images actually match, which is valid, right? That is me. That is also me. Hence, we've got a positive example. Now I'll explain this code in a second, but let's actually update this and see another example. So let's see a negative example. So the second prediction is going to be a 0. So ideally what you should see is this first photo is still me, but the second photo is going to be someone else or a different person. So 1. And there you go. So we've got different people now. So that's me, but that's definitely not me. And the output that we've actually got from our model is the fact that these two people do not match. So the third sample should be a matching example. So let's go to third, which is going to be index 2. So again, you can see me and me with my eyes closed. We go to our fourth example. That is going to be a non-matching example. So you can see it's got a 0 value over here inside of Y true. So if we run this, non-matching. So that is me, but that is definitely not me. So again, you can see that it is pretty accurately working. Now let's take a look at the code that we wrote there. So we wrote 6 different lines of code. So the first line of code is setting the size of our image or the size of our plot. Set plot size. And for this, we're using matplotlib. So remember, we imported matplotlib right at the top here. So we wrote from matplotlib import pyplot as PLT. We scroll on back down. Where are we? Yeah. So I've written plot.figure. And then to that, I've passed through one keyword argument, which is fig size equals, and then a tuple, which has the values 18.8. This controls how big the plot is. So if I wanted a smaller plot, I could change this. So say I said it's 10.8, it's going to make our plot a little bit smaller so we can see it a little bit more accurately. So if I set it to 18, it's going to be huge. Actually, 10 is probably a better example because you can see that a little bit clearer. Okay, so that is the first line, which is setting our plot size. Then because we're actually plotting 2 images side by side, what we're actually doing is we're using a subplot. So set first subplot. So what I've written there is plot.subplot equals 1, 2, 1. So what we're saying is we're going to have, I can't actually remember how this works. So plot.subplot. All right, so we're specifying the number of rows, the number of columns, and the index. So the number of rows is going to be 1 row. So you can see that we've only got 1 row there, and we've got 2 columns. So 1 column and then 2 columns, and then inside of those, we're specifying the index. So we've got 1 image, and then the first image, and then the second image. So I think we could actually tweak this a bit and actually just have 2 columns. Let's try that. So if I set that equal to 1, did that. Nope, got errors. Never mind. All right, so we've actually got, we've gone and screwed that up. So 1, this should be, there we go, cool. So we're going and setting our first subplot. So I've written plot.subplot, and then we're passing through the number of rows, the number of columns, and the index. So that's going to be referencing this image here. So if I change this value in our next line, which actually determines what to actually plot, it would change this value. So if I go and change this to 2, you can see that I've gone, it's me just smiling out of sheer happiness for doing deep learning. So we've gone and changed that second index, which is changing this image. So that is controlling, all of this is controlling this image here. This second section is controlling our second subplot. Right, now the second line that we've actually gone and written to render this is plot.imShow, and then we're passing through what we actually want to render. So I've passed through test_input, and then we've passed through that we want index number 2, which is what we originally got from over here. So this is the image that we got from our test data batch. So if we wanted to change our image, we could do that. And remember, these 2 indexes should be the same to ideally show that you're looking at the same sample, because they're going to be in ordered flow, right? So the second line is plot.imShow, test_input, and then we're grabbing the third or fourth index, which is going to be index key 3. And then we're effectively doing the same down here for our second plot. So I've written plot.subplot. In this time, I'm specifying I'm passing through the first row in the second column, or within the 2 columns, and then we're specifying what index number 2 is, which is going to be this image over here. So 1 row, 2 columns, and then this is going to be the value in the second column. Cool. Then the next line is identical to this over here, but rather than passing through test_input, we're passing through test_val, which is because we're grabbing our validation data, which is coming from over here. And then I've written plot.show to actually show it nice and clearly. So if I delete this, so you can see that we get this little line over here, which is just a function from matplotlib. If I add plot.show, it renders cleanly. And there you go. Those are our images rendered. So again, if we wanted to go and run this on a different batch, what we can go on ahead and do is run this line over here, because this is going to go and grab the next batch, remember. So if I go and do this again, or run through the pipeline again, bang, 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 calculate our precision metrics, which again still looks good, but now our images are changing. So what are we looking at? We're looking at the fourth index, which is going to be 1, 2, 3, 4, which is a non-matching sample, which you can see there. So these 2 people don't match. If we go and grab the first value, these people match. They're both me. Pretty good, right? So that ideally shows that our Siamese neural network is working in this particular case. Now, the last thing that we're going to do, and this is really step 6, evaluate our model. Now done. So we've gone and done a ton of stuff there. So we imported our metrics, we made our predictions, and remember, to make our predictions, all you need to do is use Siamese model.predict. That's going to allow you to predict or make predictions. And then we also calculated some metrics and did some visualization. Now, the last thing that we need to do, as is always good practice when building deep learning models, is not to add just more rows, is to actually go on ahead and save our model. So this is what we're going to do now. Now, there's a couple of nuances here, because we have gone and created a custom layer, which is our L1 distance layer from, I believe this was section 4, whatever. Yeah, section 4. So we went and created this L1 distance layer, which we need to do a little bit of tweaking to our export to make sure that we save. So let's go on ahead and do this. Alrighty, so let's go on ahead and save it. Okay, so the first thing that we're going on ahead and doing is saving our model weights. So I've written Siamese_model.save. And then to that, we're specifying what we want our model weights to be called. So in this case, I've written Siamese model.h5, which, if we go to where we're currently working from, so YouTube, Face ID, you you can see it's now saved. And so the date is the 14th of the 10th, 2021. So you can see that that is our model now saved there. Let me zoom in on that so you can see that a little bit better. So you can see that's our model there, Siamese model.h5. Cool, that is the first bit now done. Now what we actually need to do is do that slight customization to be able to reload this. So let's go on ahead and do that. Okay, that is our model now reloaded. So there was a little bit of customization that I had to do in the second part to be able to load up our custom models. But let's actually take a look at the full line of code that we've written. And again, it is just one line of code. I've just split it into separate lines. So I believe we can just do that to go into separate lines. Nope, never mind. Cool, that's our model now loaded. I think we can delete that, can't we? Yeah. Okay, so what we've gone and written is model equals tf.keras.models.load_model. So this line over here actually allows us to load a model up from our H5 weight. So if I go and take a look at that, so the documentation says, let me zoom in on this so you can see it. So this function actually allows us to load a model saved via model.save. So that's effectively what we're going and loading up now. Now, what we can also do is I believe we can also load up our weights. So save model.load weight. So you've also got the ability to do that as well. But in this case, we're going to do it this way because that's the way I've developed the rest of the tutorial. So just follow this way, guys, please. Okay, so I've written model equals tf.keras.models.load_model. Then the first positional argument that we're passing through is the name of the file that we've gone and saved as, which in this case is going to be Siamese model.h5, which is what you can see there. So that's pretty sort of straightforward. There's no real issues there. The second bit, which is very important, is actually going and loading our custom objects. Now, because we've got these inside of our notebook already, we don't need to do anything else aside from that. But when we go and actually build our Kivy app, this is going to be really, really important because we're going to need somewhere to reference to our custom layer. But I'm going to show you how to handle that later. Perfectly fine. So the second keyword argument is custom_objects equals, and then we're passing through this dictionary here. So it's squiggly brackets, and then we're specifying L1 dist, which is our L1 distance layer, colon L1 dist, which is effectively our L1 distance layer, which is what we created from, again, it was inside of step 4. And we've done a ton of stuff here, which is this over here. So this is our custom Siamese distance layer. All we're doing is we're passing that through as a custom object down here. And we are also passing through binary cross entropy, which is going to be this key over here. So binary cross entropy, and then colon tf.losses.binary cross entropy over there. And I believe this is because we probably created a separate key for it. Now, if I remove this, this is actually going to cause a whole bunch of errors. So what you're going to see if you don't pass through the custom object is you're going to get this error here. So it's going to say value error unknown layer L1 dist. And this is because that is a custom layer. So if we went and added that back in, let's just go and add our L1 distance layer for now. Okay, so it looks like we didn't need the binary cross entropy bit, but in this particular case, looks like it's worked. So again, by passing through that custom object, we're able to effectively load up our custom objects. Now, I'm going to leave in that second line because I don't know what that's going to do if I remove it. But in this particular case, that's worked successfully. It looks like you might be able to drop this off as well, but who knows? Might need to do some more digging into it. If anyone in the comments knows, let me know. All right, cool. That is our model now reloaded. So if we wanted to go and use this model now, we could type in model.predict and then pass through our, test input. Test val. You can see we are now getting predictions. So that is effectively showing how we can go and evaluate our model, make predictions, save it down, and then reload it. So we can now get to actually deploying and building this up into an app. Let me just double check that we didn't have anything else there. Nope. And again, we can go and take a look at our model summary. So again, we've got the exact same architecture that we had for our model up there. So let me just add some comments. So make predictions with a reloaded model. and then view our model summary. Cool, so that is about it for this tutorial. So we have gone through a ton of stuff. So we've gone through inside of step 6, we imported our metrics, we made predictions. And remember, we can make predictions by grabbing our batch. I'm gonna show you in the next couple of episodes how you can make predictions with a non-TensorFlow data set, so you can see how we'll actually productionize this as well. We made a bunch of predictions, calculated some metrics, visualized our results. We then went and saved down our model so we can begin using it elsewhere. But on that note, that about wraps it up. Thanks for tuning in, guys. Hopefully you enjoyed this video. If you did, be sure to give it a big thumbs up, hit subscribe, and tick that bell, and let me know how you went with this and if there's any changes or any help that you need. Thanks again for tuning in. Peace.